Hi guys, this is Additional Mathematics Form 5, Chapter 2 Differentiation Formative exercise. This is the exercise that you have in your textbook. Okay, so today we're going to go through this, right? There are only 5 questions in this formative practice exercise 2.4. Okay, let's start with the first one. Okay, now the diagram on the right shows part of the curve y equals square root x plus 1, the tangent and normal to the curve at point P intersect the x-axis at Q and R respectively. So now let us just focus on this. We start off with the tangent. Okay, when you differentiate, you're actually getting the gradient of tangent. So if I want to differentiate this, right, it's best we write as y equals x plus 1 to the power half. Yeah, this is differentiation for composite function. So when you differentiate dy dx, you bring the power down, you copy x plus 1, reduce the power by 1, and remember to differentiate inside the bracket. But fortunately, when you differentiate x is just 1, so it doesn't make a difference. And for me, when you have a power negative, just bring it back down, right? 1 over, there's a 2 in front here, and power half means square root, so I'll change it to square root x plus 1. Now, at point P, as you can see here, your x coordinate is 0. So we substitute x with 0. So you get 1 over 2 square root 0 plus 1, which is just half. So this is actually the gradient of tangent at point P that we are referring to the green line here. This line, sorry, the green line is your normal, the blue line here. Yeah, the blue line is your tangent, the green line is your normal. A line that touches curve at one point is your tangent, and when you differentiate and substitute the gradient, your dy dx is your gradient of tangent. Now, I need to find equation of tangent. Since I know P is actually your y-intercept, right? 0, 1. That means your y-intercept is 1. So we can just use a simple y equals to mx plus c. That is, my gradient of tangent is half, my y-intercept is 1. So the equation of tangent at point P is just y equals to half x plus 1. Okay, now to find the coordinate of point Q, Q is your x-intercept. I read the question, they say the tangent normal to the curve at P intersect the x-axis at Q, right? So Q is your x-intercept, and we know at x-axis your y is 0. Maybe I'll just write here x-axis, my y is 0. So 0 equals to half x plus 1. So my half x is negative 1, x is negative 2, so Q is minus 2, 0. Okay? Not too difficult, right? Now for part B, you're looking for equation of normal. So we already know the gradient of tangent, which is half. We know tangent times normal must be negative 1 because they are perpendicular to each other. So my gradient of normal at point B is just negative 2. And again, to find equation of straight line, I'll just use y equals mx plus c, because we know point P is your y-intercept, so your y is minus 2x plus 1. Remember, P is 0, 1, so your y-intercept is just 1. Now, to find the coordinate point R, you can see that your normal, yeah, this is your normal. Let me highlight for you. This is your normal. This line is your tangent. Your normal intercept the x-axis at point R. So we say at x-axis, your y is 0. By letting your y be 0, we can find our x. Our x is half. So R is half 0. Okay, next, how do you find area of triangle PQR? Okay, now maybe I draw this out for you. Yeah, you can see from the diagram, just redrawing for you. Q is minus 2, 0. R is half 0. Now P is a point in between 0, 1. Not exactly in between, it's actually closer to R than it is to Q. So we can see that this is actually a triangle, yeah? And the base is actually measured from Q to R, which is minus 2. You can say half minus minus 2, so it's actually 2.5, or you can write 5 over 2, and the height is just 1. So to find the area of triangle, right, we'll just use half times base times height. Yeah, so area of triangle PQR is just 5/4 or 1/4 square units. Alright, so that is for question number 1. Okay, so let's move on to question number 2. Okay, number 2 is quite similar to number 1 because you are also finding the area of triangle at the end. But first, we need to find the values of A and B. Now, read the question. They say the tangent and normal at P, AB, right? The tangent is perpendicular to this straight line. Now, this straight line is not shown. You can see it's not in the diagram. But one thing, when we know that the tangent is perpendicular to this straight line, the straight line can be somewhere here, right? Somewhere here, let's say. And we know we have to use m1 dot m2 equals -1. Yeah. So maybe I start off with this equation, 2y equals 4 minus x. I find the gradient of this line by dividing it with 2. Now 4 divided by 2 is 2. I just put it aside. A negative 1x I divide by 2 is negative half x. So my gradient of this line is negative half. And if this line is perpendicular to your tangent, you multiply with your tangent, you should get negative 1. My gradient of tangent is now 2. Remember, dy dx is basically gradient tangent. So we know we have to differentiate. When we differentiate this function, go back to this x squared minus 4x plus 1. When you differentiate, you get 2x minus 4. Now, we substitute your gradient of tangent with 2. Okay, since you are finding x, I bring the 4 over. 2 plus 4 is 6. X is just 3. 6 divided by 2 is 3. So I've got my x coordinate. I need to find my y coordinate. So I just sub inside your equation of curve. Now, please don't sub inside this equation because this is another line. Now, point P does not lie on the line. Point P actually lies on this curve here. So you want to sub inside equation of curve, 3 squared minus 4 times 3 plus 1, 9 minus 12 plus 1 minus 2. So from here we can tell that this coordinate of point P is actually 3 minus 2, right? P is 3 minus 2. Therefore, your A is 3, B is minus 2. Okay? Now, the second part, we are finding equation of tangent at P and coordinate of B. Now, the tangent we will have gradient of tangent. We just have to form the equation y minus y1 m x minus x1, right? So your y1, I'll take point P minus 2. My gradient of tangent is 2, x minus x1 is 3. So y plus 2 is 2x minus 6, y equals 2x minus 8. So this is your equation of tangent, yeah, at point P. Now, how about coordinate point B? Now, B is your x-intercept. Now, again, similar to the question number 1 just now. At x-axis, your y is 0. I'll just let this be 0. Let us solve for x. X is 4. So, your coordinate point B is just 4, 0. How about equation of normal? Next, I'm finding equation of normal. I found point B already. I need no gradient of normal. Now, previously we know that this line here, yeah, let me just say this line is 2y equals to 4 minus x is perpendicular to your tangent. If it's perpendicular to the tangent, it must be parallel to your normal, yeah, because this is also 90 degree. And when it's parallel to normal, your gradient normal must be the same as the gradient of this line, which is negative half, right? So to form equation normal again, y minus y1, use back the same coordinate because I'm using coordinate point P here. y1, gradient of normal, negative half, x minus x1. Now, I prefer to multiply over to avoid fraction. So 2 times 2 is 4. The negative I times in. So I get minus x plus 3. It's up to you how you want to arrange it. You can bring it over and write 2y plus x plus 1 equals 0. Yeah? Or you can just leave it on the right hand side. So this is my equation normal. Okay. Lastly, I need to find coordinate point C. Okay. Now we know again C represent your x-intercept at the x-axis. Your y is 0. So by letting my y be 0, I can find my x right? So in fact, I should write this over here. I should write 0 plus x plus 1 equals 0. X is just negative 1. So your coordinate point C is minus 1, 0. Oh, I still need to find area triangle BBC. Okay, again, it's quite similar to what I've shown you in question number 1. B is over here, is 4, 0. C is over here, negative 1, 0. And P is a point below. P is actually at the coordinate of 3, minus 2. So it's negative 2 unit below the level of BC. BC is on your x-axis, so it's below. So the height, we can say, is 2. And the length of your base, if you take 4 minus minus 1, the length of your base here is actually 5 unit. 4 minus minus 1 is 5. So my area of triangle is half times the base times height, which is just 5 square unit. Okay? Alright, moving on to question number 3. Okay, diagram on the right shows the open box with the square base of side x, height h. The box is made of a piece of cardboard, area of 75. Show that the volume is given by V equals to 1/4 bracket 75x minus x cubed. Okay, so what I found is that actually the diagram is a bit misleading. This formula is only valid if you don't have this part. The question is right by saying it's an open box, but the diagram is misleading, right? We should not have this part here. So an open box means it is empty like this, all right? So when you calculate the area, because they say the area is 75, you do not count the top part, right? So a normal cuboid, normal box will have 6 faces: top, bottom, left, right, front and back. But here you don't count the top part. So if I were to draw the layout, it should look like this, but you can see it's actually a square base. Although the diagram doesn't look exactly a square, it's a square base, right? X, and the height, let's say, is h. So I'm going to call this h, right? This is h. Maybe I should make the height a bit shorter so that it's more distinct. I'll make the height a bit shorter. It's not too different, right? So this is h. This is your h. This is your h. This is h. Just square box. So you only count the base, the square base, once. You don't count the top, right? The bottom, top, you don't count. Left, right, front, back, yes, you do count. You have 4 rectangle and 1 square. So let's start off by finding the surface area. We know it's x squared plus 4xh. Let me say this again. This area here, maybe I highlight using a different color for you. Maybe I highlight this. This is xh, this is xh, this is xh, this is xh. They're all having the same area. This is h, this is x, this height is h as well. And when you sum this up, this area is 75. Okay. Now always remember, if you want to show that your volume because of this, you notice your final answer has no h. So I need to get rid of h. To get rid of h, I make h as a subject. First, I bring x squared over. Number 2, I divide by 4x. So I call this equation number 1. Now, the volume of the box is just length, breadth, height. So x times x, which is x squared, times h, right? This is your equation number 2. As I sub 1 in 2, my volume is x squared, my h is 75 minus x squared over 4x, and we can cancel these two. Let's just cancel x and x squared, right? And you always look at the final answer. We're actually very, very close to the final answer, see? So you notice the question here, they write it down as 1 over 4, and they take the x, remaining x here, you multiply inside, so you get 75x minus x cubed. There you go. That's your volume V in terms of x. Okay. Now the next thing is we're supposed to find the value of x such that the volume V is maximum and also the maximum volume. So we know maximum minimum happens when dV dx is 0. First we differentiate, and if you have a constant outside, you don't have to multiply inside, just keep it. Just differentiate inside. Differentiate 75x, you get 75. Differentiate x cubed, you get 3x squared. It doesn't make a difference. If you want to times in the 1 over 4 and then you differentiate, you get the same answer. So for me, I just leave the 1 over 4 outside. Yeah, it doesn't matter, right? Now let your dV dx be 0. Okay, and you notice If you times the 4 over, it's still the same, right? Still 0. Rearrange it, solve for x squared. X squared is 25. If you square root 25, you just get 5. Yeah, the length in this case is just 5 cm. Now you don't have to take the negative side. Yeah, the length of side x cannot be negative. So when you square root 25, just take positive 5. Okay, how about the maximum value? Now in this case, you don't have to show that it has a maximum value. The question didn't ask you to show that it has maximum. Since you only have one stationary value or one turning point where x equals 5, so we can just take this x value and substitute back inside your volume. Whatever I'm getting here should be a maximum volume. So we take 75 times 3, times 75 times 5, and then you minus 5 cubed. Okay, right? That will give us 62.5. All right. Okay, so that is for question number 3. So let's move on to question number 4. Okay, now question number 4 involves rate of change. Diagram on the right shows a plank AB of length 10 meter leaning on the wall of a building. The end A is y meter from the level ground. The other end B is x meter from the foot of the wall. Find the rate of change of end A. Now the rate of change of end A means we are finding our dy dt. Okay, if the end B slides away at the rate of 3 meter per second, that means dx dt, B is x, you can see it's x here, slide away at the rate of 3, yeah? So it's 3 meter per second, and that happens when x equals 8. Now the problem is we need to link them up. Now we know that to solve problem related to rate of change, we always have to use the chain rule. So the equation that relates these two will be y in terms of x. Now you can see y is my vertical height, x my horizontal height, and they are all related by the length of the plank, which is 10 meter. So we can say that x squared plus y squared, by using simple Pythagoras, x squared plus y squared should be 10 squared. So maybe I make y squared as a subject first, 100 minus x squared. Y is therefore 100 minus x squared to the power half. So when you differentiate, you bring the power down, you copy the bracket. I'm using composite function here, reduce the power by 1, and remember to differentiate inside the bracket. When you differentiate 100, you get 0. When you differentiate negative x squared, you get negative 2x. Now minus 2 and 2 you can cancel over here. Let me show you. You can cancel them. So you're left with negative x, right? And we can bring the power negative down. Now at the same time, because you have a power half is square root. So I'm going to write my dy dx as this, negative x over square root 100 minus x squared. Okay, now you want to find the rate of change when x is 8. So we can substitute x with 8. Dy dx will be negative 8 over square root 100 minus 8 squared. 100 minus 8 squared. 8 squared is 64. 100 minus 64 is 36. Square root of 36 is 6. So it's negative 4 over 3 if you simplify. Now, since I'm finding rate of change of y, dy dt, so we can link them up. Now we know by using the chain rule, dy dt is dy, put the dt here, add in the dx and the dx. And we already have dy dx over here. Dx dt over here. We also have dy dx over here. So we just link them up. Negative 4 over 3 times 3. Answer is negative 4. Now, unit, if you don't want to write, it's okay actually. But the answer is negative 4 meter per second. Okay, that is just part A. Let's look at part B. Part B, you're looking at the rate of change of NB. That means you're looking for dx dt, right? When A slide down, so A is dy, dy dt slide down at this rate, negative 2. And we want to find this when your y is 8, y is 6. Now, a lot of people will tend to rearrange equation, maybe make x the subject, dx dy sub y. No, don't have to do that. Why? Because we can just find out what is your x value when your y equals to 6. So you go back to this equation over here, guys. X squared plus y squared equals 10 squared. When your y equals to 6, your x squared plus 6 squared is 10 squared. So what's your x? Again, your x is still 8. That means it doesn't matter. Your x is still 8. That means your rate of change of y upon x, or dy dx, is still negative 4/3, right? Because your x value is still 8. If your x value is something else, then we have to substitute back inside your dy dx, and your dy dx will have an entirely different value altogether. But here, since the x value is the same, your dy dx value will be the same. I just have to find my dx dt value. So we use dx dy times dy dt. Remember the chain rule. Now if we were to cancel them, you always get back the same thing as dx dt. But of course you don't want to cancel them. Yeah, we'll leave it out this way. But dx dy is just the invert, the 1 over of negative 4/3. So we just invert this, so it's negative 3/4. And my dy dt already have, yeah, negative 2. Can you see? So it's times negative 2. You cancel them, you get 1.5 cm, sorry, it's not cm, it's meter per second. Okay, so that's all that is for question number 4. All right, let's move on to the last one. Question number 5. Diagram on the right shows a helicopter with a height of 135 meters from the ground. The helicopter moves horizontally towards a boy at the rate of 17 meters per second. Find the rate of change of distance between the helicopter and the boy. Now, distance between helicopter and boy is actually this distance. So I don't want to use y, because usually y we use for vertical. Horizontal I can still use s, x. I think we cannot use d either, because when you differentiate, then it will be dd. It sounds very weird. It looks very weird. So normally we use displacement s. Okay, but you want to use other symbol, it's fine. You want to use dy also can. But like I say, mostly y represent the vertical distance, x represent the horizontal distance, s in this case the displacement, if you like. Okay, so what are we finding? We're finding the rate of change of the distance between the helicopter and the boy. That means you're finding ds dt. You are finding ds dt. All right. Okay. We know dx dt actually. Dx dt is negative 17. Now, why is it negative? It's getting closer to the boy, right? So the distance is actually smaller, not positive, negative. It's getting closer. The distance is actually smaller, negative 17. So we are finding ds dt. So you need to find the relationship between ds and dx. You'll find this, okay? So that we can use a chain rule and link them up. So number one, what is the relationship between s and x? So we can say, again, we use Pythagoras, s squared is x squared plus 135 squared. So let us just put it together, and perhaps I'll just square it straight away. So this is x squared plus 135 will be a big number. 135 squared is 18225 power half. So again, when I differentiate ds dx, you got to bring the power down, and notice that it's quite similar to the question before this. Reduce the power by 1, differentiate inside, so it's x over square root x squared plus 18225. Okay, now we want to sub x with what? Now we want this to find the rate when the horizontal distance between the boy and helicopter is 72. That means when your x is 72, your ds dx will be 72 over square root 72 square, 72 square plus 18225. Okay, you may have to use a calculator. Type this in. Yeah, I got 8 over 17. Right, so my ds dx is 8 over 17. The next thing is, remember, I'm finding ds dt. So I can use ds dt, the chain rule. Add the dx here, put the dx here. My ds dx is 8 over 17. My dx dt is negative 17. So when you multiply together, you get negative 8 meter per second. Yeah. So that is the rate of change of the distance between the boy and the distance between the boy and the helicopter. Sorry. All right. That's all.